Hello guys, so today we are here to solve the challenge for the day. This challenge is about binary search tree, and we all know that given a challenge on binary search tree, we have to solve this problem in a way that it becomes easy for us to understand. So, you know, in order to solve this problem, first of all, what we'll do that we will go through this problem, we'll understand the problem, we'll understand what this problem statement is trying to convey. And after this, what we will do that we will devise an approach to solve this problem. And then we will see what is the best way to solve this problem. Uh, to so we will first begin with the problem statement itself, and we'll try to understand what this problem is trying to, tell and what it wants us to do. So in this, we are given the root of a binary search tree. Okay. So in this statement, in this problem, we are given the root of the binary search tree, and we need to convert this into a greater tree such that every key in the original binary search tree is changed to the original key plus sum of all the keys greater than the original key. See, it is asking plus the sum of all the keys, the sum of all the keys greater than the original key. The sum of all keys greater than the original key. Okay, greater than the original key. So what does it mean? It means that, you know, see, we are considering a binary search tree. So sum of all keys greater than the, let's say we are considering this node, the node 4. Okay. So this node 4, all keys that are greater than this node 4 will be towards its right. So anything which is on its right, like 6, 5, 7, 8, these are all, greater than 4. So the value of 4 will be sum of all these things plus 4. Similarly for 6, sum of all these things plus 6. So see, sum of all these things, 7 plus 8 is 15 plus 6 is 21. Okay. And see, 5 is 21 plus 5, 26. 26 plus 4 is 30. 30 plus, 3 is 33. 33 plus 2 is 5. Like this, we are, pulling the sum from all its right childs and getting that sum value and the current node's value, sum of the all its right child and the current node's value. So sum of this, sum of all the right childs plus the current node sum, and that we are putting it back to the node. And that's what all we have to do. All we have to do that we have to go towards the right of a node if there is a node which exists, and we have to sum all the all those nodes values, you know and then once we come back to the current node again, then we need to sum the right child sums value and the current node's value, and then put it back to the node, and then we have to go towards the left. So this is the approach to solve this problem. So in order to solve this problem, what we will do that we will declare one, you know we will declare one, let me get some space. So we will declare one, you know private int sum is equal to 0. And here what we will do that we will just put a check. If root is not equal to null, then we are going to call, our method. Okay. If root is not equal to null, then we are just going to call one bg method. And in that we'll be passing this root. Okay. And then here we'll be returning the root. Okay. So this bg is not going to, it's going to transform the, every node's value. And at the line number 24, we are just going to return the root. Now we will do this, private void. We don't want to return anything. So we'll do bg. And then here we will do tree node of root. Okay. And then we will, put this check here. So in this, we want to go to the right. Okay. We want to go to the right. And so to go to the right, we need to first check, whether the right node is exists or not. So to check that, we have to do it like this. Okay. And then we have to move towards the right. Okay. So once we go to the right, you know, we have this global sum variable. So let's say, we go towards the right. Okay. And we find that there is a node which exists on the right. So we keep on going towards the right. So let's say we reach here at the node 8. Okay, see, we are here at the node 4, and we check if root dot right exists, then we go towards the right. At node number 6, what we do, we check whether if the right node exists, then we go towards that right. Then again at node number 7, we check whether the right node exists, and then we go towards the right. So after we hit this, this last the most rightest node of this tree, what we do, that we take the sum. So sum is a global variable for us because we have declared it at outside all the methods in the um, in the class. So it's a basically in Java, this will be called as instance variable, and then we will increment this with the root dot val. Okay, so and then again in the root dot val, we'll be putting the value of sum. Okay, so we'll be increment putting back the sum value, and then after doing this, we need to check if root dot if for that root there is a left node. If it is, then we again call, if is not equal to null, then we again call bg of root dot right, root dot left. Okay, and I don't think we need to do anything else. So we go towards the, so suppose what it is going to happen here in this case. So 8 will, it will, uh, some value will be 0 at this point. So it will be, again, it will be 8. And then since its left child is nothing, so it will, not go towards the left, and it will go back to the previous node. So now in this case, now the sum value is 8, and the current node value is 7. So 15 plus 8 is 7 plus 8 is 15. And then we'll go towards the left. Then again, there is no left child, so it will go back to the recursion. That current activation record for that recursion will be removed from the stack, and then it will go back to the sixth node. And at the sixth node, the value will be 15 plus 6, 21, and then it will go towards the left child. And at the left child, again, it will check whether it has got a right child or not. So this sum value is 21. 21 plus 5 is 26. And then it will check its left child. If there's no left child, then again it will go back to the sixth node. So at sixth node, it will be 15 plus 6, that value will be activated. So yeah, so so from 6 again it will go back to the 30. So this 6 has been already been processed by at this point. So we'll go towards the left only after processing the current node. Okay, and then we go back to the fourth child, and that's how we are solving this problem. So let me run this and show it to you how it is performing. So let me run this and show it to you how it is performing. Perfect. It's accepting both the test cases. So now we'll submit it. Perfect. So this is beating all other solutions. So I hope you enjoyed this solution. If there is any feedback, anything which you would like to share, please post it in the comments, and definitely I'll go through those comments. So with this, I'm thanking you. Happy coding. Best wishes.